when you program for the NES, you deeply need to understand the hardware, right? And that's not a thing like as a .NET developer, you don't really know what a register is or a bus or NES has a thing called a PPU.
Welcome, friends, to the Modern.NET Show, the premier .NET podcast focusing entirely on the knowledge, tools, and frameworks that all .NET developers should have in their toolbox. We are the go-to podcast for .NET developers worldwide, and I am your host, Jamie GaProgMan Taylor. In this episode, Jonathan Peppers joins us to talk about something which is a little out of the ordinary for us here, programming the Nintendo Entertainment System, but in C#. We talk about the process behind his, some would say absurd, idea for an AOT transpiler which can convert a subset of C# over to the assembler required to write and publish a NES game.
So you think about that example, what I described there on the NES side is actually very similar to what's on the IL side, is that in IL, you have a string, right? It goes and looks up in a string table the contents of the string and puts it on a stack. And then it calls VRAM write. And then it's the runtime's job to actually make that happen at runtime. Or in the case of an AOT compiler, it would emit, native machine code that does the same thing.
Along the way, we talk about what ahead-of-time compilation is, and a brief intro into what IL is, that's what your C# code is compiled to before running, and how all of that fits in with .NES, the wonderful name for John's AOT NES compiler. Anyway, without further ado, let's sit back, open up a terminal, type in .NET New Podcast, and we'll dive into the core of modern .NET. So welcome to the show, Jonathan. My goodness, this is an episode that I've wanted to try and arrange for a while, ever since I saw a talk that you gave at one of the many .NET Confs about .NET NES, .NET NES. We'll get onto which it is in a moment. But welcome to the show.
Yeah, how are you? Yeah. I think, I don't know if it's pronounced .NES or .NES, but .NES sounds good because it looks like .NET, like with an S changed to a T. So either one is fine with me, though. Yeah.
Okay, cool. I also really, really dig the logo that's on the website, on the GitHub repo. Sorry, it's really cool. I'll put maybe a link to. I'll definitely put a link to the repo in the show notes so folks can go and get that. And if it's possible, I might try and put the logo in the episode art as well, because it is really cool.
Yeah, I had a contributor send me that. So I gave a talk at Microsoft Build about this project, and that week it was like I got PRs from people I'd never seen, and here's a logo. And I was like, and so I had to look up the person's name, but maybe we can follow up in the notes who did that. But yeah.
Totally, yeah. I'll make a point of adding that. I do like that because every open source project has to have a logo, right? Otherwise, it's not a real project, right?
Yeah. Well, sometimes I find myself asking ChatGPT to make one too soon, before the project's done. But yeah.
Cool. Yeah. Okay. So we've been talking for a little while about the project and the logo and stuff, and I've kind of introduced you to the folks listening. But I guess in the nicest possible way, who are you? What do you do?
So I'm an engineer on .NET at Microsoft, specifically .NET for Android, and also .NET MAUI. So, .NET MAUI is a cross-platform framework that sits on top of iOS and Android things. And so, as you might imagine, there's an Android team, there's an iOS team. But I do a lot of work on performance, maybe MS Build things. And this .NES project is kind of like a fun thing I did on the side that, turned into more is basically what it was.
Cool. So okay, right. So I've got a question. We've talked a little bit about .NES. Let's discuss it, right? We've talked around it. We haven't actually said what it is. So for the folks listening, what is .NET NES, .NET NES?
So I imagined a few years ago, this is probably during the pandemic, how cool it would be is if you could at the command line could type .NET new NES and then type .NET run and then an NES emulator pop up, right? And you'd have like a C sharp project, running um, an NES, valid NES game or whatever. Um, and so initially, where I started was very rudimentary. It was like that workflow worked, but all I did to start with was figure out like the string table and how to find the string you wrote in Hello World, how to change it, right? And so that was it, like version 0. I don't know, 0.001, I don't know. Um, and I had that working for a year or two, and this was a project I would come back to off and on, get more of it working. I would get different pieces working, and um, at some point, I felt like it was fully functional. I had no to-dos left in the code base, and I thought, well, let's release it. And then I thought, oh, let's submit talks about this, right? And so that's kind of where I ended up. Um, I would not claim that it's complete by any means. Like, we can get into how it works more, but at a high level, it compiles your a C sharp assembly, like as normal. Um, a lot of things in the language aren't going to work. For example, you can't create a class and allocate on the heap. Like none of those things exist. And so what you're writing looks more like a C program. Um, but of course, in C sharp, you have just a program CS with statements in it. Um, and so what it can do is it looks at the output of the C sharp compiler, which is IL, and it generates the equivalent, like NES, like binary format,
Right.
that any emulator will load up happily and not know any difference, right? So, uh,
So okay, so I have like 100 questions there. um, so okay, so from my understanding, then you're typing some C sharp code that looks a little bit more like C, but that's totally fine. You type some C sharp code, you do a build, some magic happens, and you're able to run it as if it's a Nintendo Entertainment System game inside of a Nintendo Entertainment System emulator. That in itself is genius. Um, like, I guess the first question is, you said that it was doing some lookups and sort of transpiling the code from one thing to another. Is it like how does that bit? Well, this is going to get super technical super quick. So, how does that work then?
yeah. Well, I talk about the different parts for sure. So, if you think about my day job, that is what I work on. Is that like you can type .NET New Android and you get an Android project, and then if you do .NET Run, you use an Android emulator and run your .NET program on Android. So you could see where there's a parallel there in my day job for
Right.
sure. Um, the process, so .NET's build system is, if you've seen it, it's MS Build. It's kind of arcane, but we've had it for many years. But you can extend it to do almost anything, right? Like, and this is kind of an example of doing that. You can write not only like XML files that describe what the build does, but you can write C sharp code that will run during the build to do extra things, right? And so on Android, we do things like we compile Java code, do all kinds of crazy things. zip up all the files together, sign the thing, deploy it. So this is not nearly as complicated as what I work on at a day job in some ways, but um, what was more complicated is that writing the so I knew the MS build part quite well. That's my day job. Um, but knowing the NES, it's 6502 assembly language, like learning what that is, like because it's a slightly older than I am. It's a little before my time. Like if I was maybe 10 years older, I maybe would have actually coded in 6502, but this was kind
Right.
of my first learning experience with it. Um, and so where I was is I also knew quite a bit about what the C sharp compiler outputs. Like in my day job, that's another thing we do is um, modify C sharp code during the build. Um, so I also knew that side of it. So then the missing piece was like looping over the IL. And um, if I can describe loosely what that is, it's almost like a state machine of different operations. So it'll be like put the integer one on the stack, put the integer two on the stack, and then call this method. So it looks close to the C sharp code, but in a more machine readable way. Um, and so you can imagine how you would look at this stream of, yeah, I guess you could call them operations, expressions, and convert to the equivalent NES operation. And one reason that I wanted to do the NES is that its instruction set is so small. Like it was so long ago that you can literally look at a table and it's like maybe a 10 by 10 table of all the instructions and half of the blocks are empty, right?
Right, right.
um, so IO is actually more complicated than the NES has, and so some instructions end up being like 10 NES instructions, for example. but
Right.
um, but if you think about it, this is what .NET does on all the platforms, right? So let's say you're on Windows and you run a C sharp program. The only difference is instead of doing it at build time, they actually do it at runtime um, by default. So the core CLR runtime is some code that's written in C or C++ that knows how to load IL and convert it to your machine's instructions at runtime and very quickly as well. Like that was one thing I didn't have to worry about here was that I'm doing it build time, so no worries about performance. So
Right. Right.
uh, so if we wanted to talk a little bit about AOT, um, that's basically what I did here. Is I wrote an AOT compiler for the NES, and .NET has different forms of AOT.
Just like,
uh,
I'm sorry, but just like that phrase, I wrote an AOT compiler for the NES.
yeah, yeah, and the different AOT technologies, that .NET has. Some of them are written in like C. I had the um, I don't know, luxury that I could just write everything in C sharp, right? So I I feel like it was an easier time. Um, um, so like if we wanted to talk about AOT a little bit, so on Android, the product I work on, also iOS, um, we use a form of AOT that came from Mono or came from
Right.
Xamarin. Um, and it's a technology that like basically runs Mono's JIT compiler at build time and then
Right.
outputs some files, and then we put the files in the app. Um, and the reason this was required originally is iOS can't actually JIT because Apple restricts it
Right.
At runtime. You can't create or write to a piece of memory and execute it. Like you can't do that on iOS at all.
Okay.
And so Xamarin brought this technology for that reason, but it also was useful on Android because it could make apps launch more quickly. So, um,
Right.
yeah,
So if we could just break for a second there and just cover a few things that you were saying then. So for those, just so that, because we have people who listen from all sorts of different levels in their .NET journey. So when I type my C sharp code and I hit build, it will produce a binary of some kind. On, I guess on a Windows machine, it might produce an exe, and on a Linux or a Mac on the a Mac or a Linux on the desktop, it might produce like some kind of DLL that then has to be loaded and run. And what we were saying is that the C sharp code is converted into IL, which is literally stands for intermediary language or intermediate language. I'm not sure. It's one of those two. And then when you run, the JIT compiler, the just-in-time compiler, comes along and converts those. I've never been sure whether it's single line at a time or a couple of lines at a time, but I feel like it's probably a single line or a batch of lines at a time so that it can do branch prediction and stuff. And then converts that, like you said, to the bytecode for the CPU architecture of the machine that you are running it on, right?
yeah, yeah, yeah.
And
It
I
does it
guess,
per method,
right,
um, and so it gets complicated when you think about it because of things like when it first sees a type for the first time, it has to run the static constructor of the method or JIT the static constructor of the method.
right.
Um, and then it can do the method, so there's definitely some timing there. Um, so maybe I could talk about a console app. I'm trying to think the easiest thing here. So if you created just the console app, you can imagine it's Visual Studio or .NET New Console. Um, when you go to build, be that F5 or .NET Run or .NET Build, it's going to run the MS build engine, which will run a bunch of logic, and then in the middle of that, call the C sharp compiler. And so uh, the C sharp compiler will output MSIL, Microsoft Intermediate Language, in a DLL file.
Right.
Um, but there's like I did as I hooked into the build after that step to make .NES work. Uh, but you could also do additional things. So, like, let's say you published your console app and you wanted it to be self-contained. Um, so what that means is you want to run it on your grandma's computer, and she doesn't have .NET, right? Uh,
Right.
and so in that case, it can actually create a file that you can share, and it has .NET contained within uh, the console app. So you can do that. It's .NET publish dash dash self-contained. Um, and you may have to set another property to say produce a single file. And when you do that, it'll create a native XE for Windows, for example, and it basically zips up and embeds all the IO inside. And so when you click the XE to run it or launch it, however, um, it has the runtime inside. So it has a copy of the C++ code that knows how to extract all your IL at runtime, convert the IL to instructions that'll run on that current computer. And it's actually pretty amazing when you think about like the tech behind, what makes Hello World run, right? Like,
Yeah, yeah. It's like using a car to start a car, right?
yeah, yeah. Um, so you can go a step further with that, like that same console app we're talking about.
Mhm.
By default, it will use the runtime. It's called Core CLR. That's the one that's stable. It's in .NET 9. It'll keep going. Um, but you can also publish it a different way. So you can say add a setting publish AOT equal true. And this is not Mono's AOT. This is a new AOT that, different people have been working on called native AOT. Um, and so instead of producing this exe with all the IL like compressed and zipped inside of it, it actually does a very similar thing to what .NET does. It has an AOT compiler that outputs just native code. Um, so there's a lot of choices in .NET when you get down to it. So
Right, right. And I can imagine that there's a lot of hand waving wizardry going on from my perspective, because the AOT stuff is wizardry from my perspective. But I can imagine that, like, in a 10,000 foot view, is the AOT, let's say the native AOT, is that doing like the pre-compilation, right? It's doing that step during your publish time. It's taking all of your IL and converting it into that bytecode for you. Is that what's happening?
yeah. So they have MS build logic that after the normal build, they'll run a step called the trimmer, and we use this on mobile as well. But it will remove any code that it thinks isn't going to be called to get the app smaller, right? And then after that, it will run a step called ILC or IL compile. You could think of it as that, right? Um, that calls a native like C tool chain to write native code instead of IL. And so if you created a native AOT app and sent it to someone, like to them it's just like another computer, it's just another native app. Like it's almost like you could have written it in C.
Right.
I'm sure you could inspect the binary and figure out that .NET is involved inside, but for what you know the OS is concerned, it's like just a native thing, right? Like so,
Right.
yeah,
Okay. And that pre-compilation stuff, that native AOT, that then I guess one of the benefits of that is that perhaps it may run a little faster, might use slightly fewer resources because it's not converting the IL code to native code at runtime, right? It's already done that bit. And so my guess is, well, okay. So I know that in most cases it will. I'm just sort of like filling in for the listeners who may not know what AOT is. It's obviously going to produce a binary that's a fraction smaller and
yeah,
it runs a little faster, right? I guess that's one of your benefits of
yeah.
AOT
So
compilation.
let's say that you had a method. I don't know. Let's say that it's got 100 lines of code. This method. Um, if it was with native AOT, all the code is already compiled and it just basically runs it, right? Where if it's using the JIT on Core CLR, it first reads through the IL, and then does a step of converting the code to the machine's architecture. Um, so native AOT is going to be smaller because of the trimming. Um, also, start quicker because there's no jitting step. And then the memory usage will also be smaller because it doesn't have a copy of the IL in memory. So sometimes they'll say like the working set is what people will say is the metric that's much smaller in native AOT. But then if you think about like an ASP.NET web service, the JIT can be better in some ways. So let's say that you have a monster web server, that's running your ASP.NET, whatever, web API. Um, the JIT can actually better optimize code paths because it has a tiered JIT where it will first get some code out there as quick as it can. That's like tier 0, tier 1. Um, and then if the same code path is called over and over, it has an opportunity to optimize the code path further. And so, using Core CLR in a web service may actually be what you want because you'll get more throughput. Um, but you'll have higher memory usage and startup will be a bit slower. But those things you may not care about in a web service, right? Like, um, usually you're not restarting your web server all the time, hopefully,
Yeah.
right? So,
Yeah.
so native AOT is, it's really useful for small things that you're going to run, or maybe mobile apps, which is where, my daily work is where we're interested in it. Um, So, because mobile apps, you've got that like time where a customer is tapping on an app icon and they want the app to be there quickly, and it's not trying to use your computer's resources 100% like a web server
Mhm.
would. So, yeah.
Yeah. Okay. So then, so I guess the one of the many drawbacks of doing native AOT, and we'll get back to .NET NES in a moment, because you were about to talk about how that's linked to .NET NES before I stopped you, paused you. So like, I guess one of the drawbacks of doing native AOT, because like somebody's listening along going, why don't I just do this anyway, right? And I guess one of the drawbacks is longer build times, more time spent doing that build, and then maybe there's some stuff that you can't do, right?
Yeah, yeah. Native AOT does have some limitations. When you think about that trimming step I mentioned, there's a whole class of things that you can do in .NET that a trimmer can't figure out. And so there are a set of build warnings that will tell you this, the trimmer or AOT warnings. And it's usually around the use of reflection. So you can use system reflection as long as they can figure out what's happening at build time. So if you're turning a string into a .NET type, that's the kind of thing that won't work in native AOT. So like imagine you're parsing some JSON or something like that. Um, what you would do instead of using system text JSON as is you would have to use their source generator. And so what that does is at build time, you get this JSON parsing logic that knows the types, and then um, you know the native AOT compiler is completely happy with that, right? It's almost as if you would have written the parsing code by hand, is what the source generator outputs. Um,
Mhm.
but then if you imagine, JSON object.parse and then put a string in there, it is probably not happy with that
Yep.
type of implementation. Yeah.
Sure, and that is because in your example there, where you're parsing or deserializing that JSON back to some object or other, something somewhere, presumably with reflection, has to go look at that C# object and go, okay, cool, I'll create a new instance of this and then figure out how to map the keys and values to those properties using whatever magic reflection does. I appreciate reflection, and but I've never really looked really deeply into it. It's one of those things that's on my list of things to do to understand
Yeah.
C# and .NET a lot better. But like the fact that a program can interrogate itself is wild to me.
Yeah. Yeah. Well, and it's also slow. Um, so there's two wins there. Is that if you get a piece of code to work with native AOT, it's probably going to be faster in general because it made you get rid of the reflection.
Mhm.
So it's kind of a double win. And what would happen? Let's say you didn't fix it. What would potentially happen is you'd get a build warning, and then at runtime, if the type was removed, like it wasn't used anywhere in your program, you would get like a type not found exception, method not found exception, that kind of thing. So I do think it is easy to figure out what to do to fix it. as long as there is like a good alternative. So
Yeah.
yeah.
Yeah. Um, that's really cool. I like using a source generator to throw some code in there to figure out the bits that you might need. Like in your example there of if you included a source generator for some JSON parsing, it would figure it all out for you. That's because like that's the other side of the magic wizardry is like code that writes itself. Like that just it blows my mind.
Yeah, I've not written a source generator. That is a thing that it's another thing to learn. Like learning MS Build is one thing, but like learning Roslyn and the C# compiler is another, right? Like
Yeah,
there's a
yeah.
lot of
It's a whole can of worms.
yeah, yeah.
The following is a paid advertisement. Welcome back, .NET enthusiasts. This is another episode of the Modern .NET Show, and today we have a unique collaboration with industry expert Jamie Taylor. Known for his insights on our show over the past 7 years, he now brings those expertise to your doorstep as an external contractor at RJJ Software in both B2B and C2C engagements. Jamie has been instrumental in helping businesses across the UK harness their digital potential through custom software development tailored to their specific needs. For our US-based clients, he's facilitated transformational change by integrating cutting-edge AI technologies into their systems, all while maintaining his stellar reputation as a thought leader in the field of .NET and software consultancy. Whether your company is looking to elevate its UK operations or reshape its US strategy, Jamie can provide tailored solutions that exceed expectations. Reach out through RJJ Software today and let's unlock your business's digital potential. The audio for this advertisement was created with AI.
Cool. So okay, so so now that we've had a little bit of a primer on AOT, how does that all fit in with .NES then? Because I interrupted you and was quite rude when I did that, but like how do we get from C# through AOT to a Nintendo Entertainment System compatible game?
Yeah, yeah. So you can imagine I wrote some C# code that there are libraries that let you open IL with C#. As you can imagine, the Roslyn C# compiler itself uses some of these, right? So the one I use is a library system.reflection.metadata. And that just lets you open IL files, like DLL files, and look at the types inside and then look at the instructions, and you could do what you will with them. So then on the other side, so you can imagine I have this loop looking at the instructions in your program.cs. And then on the other side, I want to output 6502 binary. And to do this, I took like maybe it's a reverse engineering approach. I don't, but I found a really nice website called 8bitworkshop.com. And what it lets you do is in the browser, you can write NES games in C, and you can just like download the ROM and load it in an emulator. You can also see the disassembly of the C code, which is kind of what I needed to see. You can also see some of the memory instructions if you wanted to debug the game. But that was my starting point, is that I took literally Hello World in that website and then looked at, like, designed what a C# equivalent would be, and then got the IL, and then tried to write the same, binary file on the other way, right?
Right.
So this took quite a while. In the beginning, like I said, I just replaced the strings around. I learned that, hey, at this index, the string table starts here. It's ASCII. Each string is delimited with, a 0 byte. And so you could see where I could turn a C# string into the table. And then at that time, I also just took slices of the ROM and saved them as different files. So the very first version was here, copy half of this file. Okay, write the string table. Okay, write a few, and maybe it was like one instruction. Okay, write the last part of this file. And then that worked. And so that was like the light bulb moment of me like, oh, maybe this thing could really work end to end, right? And so since then, I actually if you write an NES game in C, the library that's most commonly used is called NES lib. And it looks a lot like, what C sharp APIs would use. And so I leaned into that library. Um, but some of the things I had to do was to um, write the contents of NES lib in the beginning of of the NES ROM so that it can be used by, developers who want to call it, right? And then I write the user's program and then probably a few tables at the end is what you end up with. Um, so does that explain a little bit? It's hard.
It,
Yeah.
it does, yeah. So so then just to dial back a little bit then, so you were saying that you took the output of, say, a hello world from 8bitworkshop.com and you reverse engineered how to get some of maybe MS Build to take some of your IL and convert it into that assembler, I guess, or that C sharp. Yeah, it will be assembler. It won't be C++. Well, it'll be the actual, or is it writing the binary? Like how? Okay, so real quick, how does like an NES ROM work? Like the file, the
Yeah.
.NES, right? Because you're writing to that in the correct format, right?
Yeah. Yeah. So you could, so I could have chosen to output assembly text files or C files and call some other compiler to compile them. But I instead, maybe, I don't know what made me chose this path, but I wrote the binary directly. And so
Right.
um, what that means is that in C sharp, you'd use a type called binary writer. And that just lets you write um, any byte sequence you want. And so you can just write the full ROM using binary writer. And that's all it really does. So the NES file format is interesting. It's got a header that's like so many bytes, and it's literally the ASCII letters NES and then some other random bits. And then that's the first like 10 bytes of the file. Um, so I wrote code that did exactly that, right? Like called binary writer and wrote the header, right? And so I'm like, okay, I wrote the header. Um, and so then it's learning the rest of the structure is you've got um, a table of just random code. You've got a table of strings. Uh, you've got there's tables of different. Well, what's the easiest way to explain this? So when you program for the NES, you deeply need to understand the hardware, right? And that's not a thing like as a .NET developer, you don't really know what a register is
Mhm.
or a bus or like NES has a thing called a PPU or I guess what is that? Something
Pixel
processing unit,
processing unit.
pixel
Yeah.
processing unit. Yeah, yeah. Um, so there's a table of data um, that also has an image, like a single sprite sheet of your entire game. Um,
Right.
so there's a table to interact with all the hardware to have a sprite sheet, and that's all in the format of the ROM. And like I said, this was like a multi-year passion project of me figuring out. So like along the way, let's say I figured out um, the sprite table we talked about. Um, that was one piece. Oh, but the project's not done. Let's say then I figured out how to get a full C sharp program emitted. That's part of it. Well, but it's still not done, right? Like it took a while to get the whole thing end to end working. So
Okay. So what? So what came next then? So you have this table of tables of data and tables of presumably instructions. Um, uh, yeah. How did you get from where you were, where you had a little bit working, to the whole thing, the whole schmear, the whole shebang? Like what? Like yeah, it's breaking my mind how you are writing out. You're effectively taking C sharp code, converting it into the IL from the build, and then somehow doing some magic, and then writing binary out to disk that then is interpreted by a NES emulator and just works. Like, what?
yeah, yeah, yeah. So maybe we could talk about an instruction. So what Hello World NES has in it? I'm going to just pull up an example to so I'm talking to it. Um, so you call there. Hello World has, let's say, 7 method calls to kind of set up the NES. And then at the bottom is just an infinite loop that if you exited the loop, what would happen is the NES would just keep reading at random instructions. Like it would just keep reading the rest of the ROM as if it were code. And so who knows what would happen, right? Um, but let's say, imagine that there's one function it's actually called VRAM underscore write. But imagine that says console write line, and then you put a string in it, right? So that method VRAM write, not only do I need to write like its implementation into the ROM, but I need to write an instruction that says, hey, go call this function, and here's the string that you need, right? So that's probably several instructions. It's like, go to the string table, find string number 0, put it on the stack, call VRAM write, and then VRAM write knows where to look for the string. So you think about that example. What I described there on the NES side is actually very similar to what's on the IL side. Is that in IL you have a string, right? It goes and looks up in a string table the contents of the string and puts it on a stack. And then it calls VRAM write. And then it's the runtime's job to actually like make that happen at runtime. Or in the case of an AOT compiler, it would emit, native machine code that does the same thing. If that helps describe it a little better.
Okay. Yeah. Yeah. I mean, it's making a lot more sense to me now, right? Um, so okay, stupid question time then. So, how soon Super Mario Brothers?
So I don't have as much time as I would like, to work on this. I've got kids, but occasionally I will pick up the project and continue on. And so I did that I can't remember what month. It was a few months ago. We had like a hackathon week, and I actually had a coworker help me, and he created the .NET bot in 8-bit workshop, and it has like a little visual editor. And so our goal was to get sprites working, because so far all I had was text, which is not a very good NES game, right? And then we also would like input to work, right? And so input does work and sprites work. However, the part that's tricky, as you might imagine as I described this, is to implement input, you would write code in C. Let's go back to C. You would write like if the left direction pad is down, do this, right? If the right B pad is down, do this. If A is pressed, do this. And to do that logic, there's a lot of branching, a lot of if else. And then it also, you have to do a binary like and to compare enums, like it's kind of like you would do in C sharp, right? Um, so all of those features together were not in my AOT compiler. Complicated branching, binary, and right. So we got part of the way. Like within 1 week, we got sprites working. Input would work in a simple if statement, but not enough to that you could make the sprite move around the screen, right?
Right.
We wanted to be able to use the D-pad or arrow keys or whatever and just move that .NET bot around. And we got close. If I had more free time, I think I could do it in another, day or two, so.
Right.
But that is the goal. It's like long-term goal. If I keep working on this, or if other people are interested, feel free to hit me up. Is to find a open source Mario game and port it to C sharp, and that would be like our ultimate goal. Is we first port it to C sharp, probably not take that long. Like today, in today's world, Copilot could probably do it. But getting that program to actually work is probably, a bit more involved, right? So,
Wow. I'm just imagining now, like the next big global hackathon is to get like the .NET Bot Adventures NES edition running or something.
yeah. And what's cool, I have a couple of like physical hardware devices that can load NES ROMs. And any of my ROMs that I've made, they all work, is what's amazing to me.
That's awesome. You get all your school friends together and you fire up, I don't know, like I can't even remember the name of them, but like, I know which ones you mean. Like you can get them in cartridge form, or you can get them as like a physical form factor, like the NES Classic or whatever, right?
Yeah.
You load that on there and you're like, hey guys, check this out. I made this.
Yeah. You can get like a Game Boy like device. You can get another one that's interesting. There's a device called an EverDrive, and what it is like a physical NES cartridge that has an SD card inside it, and you could put any ROM you want, and then put that in a original NES, and it'll run it. I don't own one of those. Like I don't have that hardware, but that sounds like the ultimate thing to test on.
Yeah, actually, rather than running it through an emulator, running it on the actual device.
Yeah.
Wow.
Yeah.
Wow.
Another device I have one I actually have is called the Retron 5, and what it lets you do is use the physical controllers, and then it has an HDMI output, and then you can use the physical cartridges, but you can also just pop an SD card in it and run any ROM, right? So I have used that to test my games and seen them run on a TV, but
hey kids, come check this out.
they're like, it just says hello world. What it's still.
This is the worst game ever, Dad. What are you doing? Oh, that's awesome. Okay.
Yeah.
And so like you said at the beginning, this isn't just something that you just kind of went, I know what I'll do. I have no experience with any of these tools. I'll just do it. It's kind of related to your day job a little bit, right? And I think that's one of the things that folks kind of need to remember, is that with you working on the teams that you're working on, this is, without doing it for NES stuff, this is kind of what you're doing anyway. So you had a fair amount of background knowledge into how the tooling works. inventing
Yeah.
your own tooling as you went, but a lot of tooling as you went. So like, it's kind of like how if I was building, say, I don't know, a web API for something, some personal project, right? This is kind of along those lines for you, right?
Yeah, yeah. So yeah, I was a total noob about NES programming, like 6502 assembly, like yeah. But I knew the rest. And I think if you're going to do a project for fun, I always think, make sure there's a super huge unknown in there that you'll learn, right? Like it's part of why I did it. I wanted to learn a little computer history, but it also really, I mean, I learned about MS Build. I learned about IL. Like there's other skills in there that are useful, so
Yeah.
for sure.
If you're enjoying this show, would you mind sharing it with a friend or colleague? Check out Podcatcher for a link to the show notes, which has an embedded player within it and a transcription and all that stuff, and share that link with them. I'd really appreciate it if you could indeed share the show. But if you'd like a few other ways to support it, you could leave a rating or review on your podcatcher of choice. So if you head over to .netcore.show/review, you'll find loads of ways to do that. You could consider buying the show a coffee. The Buy Me a Coffee link is available on each show's show notes page on the website. This is a one-off financial support option. You could become a patron. This is a monthly subscription-based financial support option, and the link to that is included on each episode show notes page as well. I'd love it if you could share the show with a friend or colleague, or leave a rating or review. The other options are completely up to you, and are not required at all to continue enjoying the show. Anyway, let's get back to it. That's really cool. Yeah, because like if I look back on my own, because I remember you at the beginning of this conversation, you were saying that like the 6502 is old enough so that if I were born 10 years earlier, I would have been programming with it. And what I'll say about me is one of the first bits of hardware that I ever programmed on in an education setting was a Motorola 68K. There was this like control board you had to, on the computer we were using, you had to drop out to DOS because it was running Windows 98, I think. Drop out to DOS, pull up this DOS-based IDE, type a whole bunch of assembler into it, and hit run, and it would compile the binary and send it over the parallel port onto this device. Like it was just, yeah. So I feel like I'm perhaps behind you a little bit ahead of you a little bit in years, but behind you a little bit in that aspect. I don't know.
Well, so that's 6502. It's an interesting time because other computers use the same assembly language. So like the Commodore 64, people are older than me, probably know better, but back then you could write assembly and then you could maybe get your program to work on multiple machines, which is kind of interesting. Like to us today, that's not a thing, right? Like you can't just take Windows assembly and run it on a Mac, right? So yeah. My earliest computer memory. So I used DOS when I was a kid, for sure.
Right.
But all I knew how to do was to like change to the A drive and run the game that I wanted to run, right? Like that was my beginning. And then a few years later, you would have to know how to type Win to boot Windows, right? Like those are the two things that I remember in the early days, but I didn't code until I was like 18 or something like that, right? In my life. So there's a whole thing I missed being too young there. I think that people talk about getting magazines and writing out assembly programs. Sounds like a fun time. So.
Yeah. So I never managed to do any of that, but like my experience with that flight, it was a Flight 68K board, right? And you can still buy them today, which is really cool. And I've like every so often I go, "Ooh, should I buy one?" But then I think, no, I don't have anything with a parallel port, right? So it's not going to work. Um, but yeah, that was in the early 2000s, and I was around the age of 16 when I was introduced to that piece of hardware. And then similarly, I found out that it's the exact same at the time when I was playing around with these things at college. So that's college 16 to 18 here in the UK. I found out it's the same CPU that was in the original Apple hardware and the same CPU that was in the Sega Genesis, Sega Mega Drive. So like I remember going down to the library to see if I could find the 68K book to figure out, wait, can I use this to program my Genesis at home? This would be awesome.
Yeah, yeah, yeah. And it may be back then that if they had a standard processor, they got it where it was cheap, and then everybody was trying to use the same one in their computer or console, right? Like,
Yep.
I guess it would make sense that the same assembly language would work. So
Yeah.
it's a different time
uh,
for sure.
yeah, absolutely. We've gone kind of the other way, right? We've standardized on languages rather than the hardware, and had the runtimes and the tools build the stuff for the hardware we're targeting, right? So
Right.
like
Yeah.
my understanding is modern game development probably still is in C++ with a bit of assembler where you need to really tweak the hardware, but you're probably using something like Unity, which has the ability to pull in C# to do some stuff. And when you hit build, it will figure out what you want to run it on. You can go, build for Nintendo Switch, and it will pop out a Nintendo Switch thing, or you can do build for, PC, and it'll pop out a whole bunch of PC stuff, which is,
Yeah.
it's interesting that we've kind of swung the other way, right? Instead of using one common language and hardware, we've gone, whatever the hardware is, we'll make the tooling work best, right?
Yeah. 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 And
Cool.
Unity is interesting. Like, for example, if you publish an iOS project for Unity, I don't know if it's still like this, but back when I used it in my day job, it outputs an Xcode project, and then it's up to you to go from there, take it from there. Um,
Best of luck to you.
yeah, yeah.
Wow,
Uh,
that's amazing. Wow. Okay, cool. Um, yeah, that's been really cool. I've really enjoyed this walk down an interesting path with with creating something that will, I guess, transpile directly to 6502 assembler for the NES. Like it's something that I feel like a lot of us don't need to ever do, but knowing that there is a path to convert my C# program into something that could possibly run on a very specific piece of hardware, I think is a journey that maybe IoT people need to be aware of. Or like if we ever do get to a point where there's some specific hardware, it is possible to convert C# over to that format for your hardware for whatever runtime is running.
and
I think
and
that's really cool.
if your target device you want to run this on is reasonably modern, you could have gone the other way, where I went from scratch because the NES is so old. There's no chance, right? You could go look at the native AOT compiler and look at what it would take to make it output native code in the new format. And the benefit of going that way is that anything in .NET would work, right? Like, but
Yeah.
of course, there's going to be different challenges taking that approach. You're like working with existing code, probably a bit to learn there. And then if you want to try to contribute back the work, like you might get code review from the .NET runtime team. So, but yeah, that's also an option, right? To go make native AOT run on the new platform. So
Right. Now I'm trying to figure out whether whether you could go the other way and do native AOT to the NES, right?
yeah, the part that I don't know is if you could get the code small enough. Because you have a very limited number of bytes to work with. So does the GC fit in there? I don't know. That's That's a question.
Yeah. Do some extreme trimming.
Yeah. Yeah.
Awesome. Awesome. Well, I mean, I've had a huge amount of fun, Jonathan, so thank you for this. And I've learned a whole bunch about like the tooling that builds my code as well. Knowing that like MS Build has this extensibility to be able to throw stuff in to do a part of that packaging process, do some extra code. Like I still want to learn one of these days about source generators because that's just proper magic wizardry. One day I will learn about them. But for now, I'm happy just going, yeah, cool, the source generator, it's doing some stuff. There is stuff being done there, and I don't know what it is, and it's awesome.
Yeah. Yeah. Yeah.
But, what I'll say, Jonathan, is that we're coming close to the end of our allotted time together. I know you're a very busy person, probably going to go off and play some NES games, aren't you? So if Jonathan's boss is listening, no, he's not. He's going to go and do lots of really, really difficult work, and he needs a raise. That's what I will say.
Sounds good. Yeah. Yeah. No, this has been great. Yeah. I always happy to talk about this project. If you're interested, you could file an issue. I also have a Discord server if you want to just hop in there and chat. we can talk. So anybody who's listening to this, feel free to join in if you want.
I will get the links for the repo and for the Discord server and put them into the show notes. So people should definitely join those and take a look because, yeah, I mean the code in the repo is really, really well put together too. So like it's what I mean by that is it's looks great, but also reads really well for people who don't know what this is. Like if you know C#, you can follow this repo, right? It's not really doing anything supremely magical. It's still the C# that you know and love. So folks should definitely go check that out.
Yeah. Yeah. Sounds good. Well, and thank you for kind words.
Hey, no worries. I only tell the truth, right? So what about if folks want to ask you a question or talk to you about this? Is Discord the best place to go if they join the Discord server?
I also have discussions enabled on the GitHub repo, so you could go there if that's easier.
Okay.
I'm on different social media, but I don't check that quite as bit as GitHub. GitHub is my ultimate social media, right? So
Yeah, right. That's what it was created for, wasn't it?
Yeah.
Amazing. Well, Jonathan, I want to thank you for this wonderful conversation. There's a whole bunch of stuff here that, sometimes we have to step out of our normal path, the normal journey that we take every day into slightly the absurd to learn something new. And I love it. I absolutely do. You've inspired me to go figure out if I can find any of my old 68K books and try and do something similar, but with .NET. I think that would be cool, right? .NET Genesis.
Definitely possible. Yeah, definitely. You could do the exact same thing, I bet. Yeah. So.
Yeah, well, I mean, the sky's the limit, right? Why not?
Yeah.
Amazing. Well, thank you very much, Jonathan. I've had a wonderful chat today.
Yeah, thank you.
Thank you for listening to this episode of the Modern.NET Show with me, Jamie Taylor. I'd like to thank this episode's guest for graciously sharing their time, expertise, and knowledge. Be sure to check out the show notes for a bunch of links to some of the stuff that we covered and a full transcription of the interview. The show notes, as always, can be found at the podcast's website, and there will be a link directly to them in your podcatcher. And don't forget to spread the word. Leave a rating or review on your podcatcher of choice. Head over to .NETCore.show/review for ways to do that. Reach out via our contact page at .NETCore.show/contact or to join the Discord server at .NETCore.show/discord, all of which are linked in the show notes. But above all, I hope you have a fantastic rest of your day, and I hope I'll see you again next time for some more .NET goodness. I'll see you again real soon. See you later, folks.